Let's look at the next question. The next question we do is question number 6. Before we start, let's quickly revise the formula that we need to use in this exercise. Density is equal to mass upon volume. Upthrust is equal to volume of the solid, which is under the liquid, multiplied with density of liquid, multiplied with gravity. And the last one was apparent weight will be equal to weight in air minus the upthrust. So these are the basic formula that we need to use in this exercise. We've already solved a few questions. Let's look at the next one. Mass of block is 13.5 gram. So mass is equal to 13.5 kilogram. Volume is 15 into 10 to the power negative 3 meter cube. Calculate upthrust on the block if it is held fully immersed in water, which means the full volume is under water. So we need the density of water, which is given. So let's just calculate. Number 3, upthrust would be equal to volume, which is 15 into 10 to the power negative 3 multiplied with density of liquid, in this case 1000 multiplied with G. So this would be 15 kilogram force. So upthrust is 15 kilogram force. Part 1 of the question done. Let's look at part 2 of the question. It says, will it float or sink when released? Okay, so for that we need to know the weight of the solid. So weight in air would be equal to 13.5 kilogram force into G, that's mass into gravity. So that will be 13.5 kilogram force. And upthrust is 15 kilogram force. So since upthrust is more than weight in air, therefore mass of block will float in water. So part 2 of the question also done. Mass of block will float in water since the upthrust is more than the weight. Next, what will be upthrust on block when floating? So we've discussed this earlier. When an object is floating, whenever an object floats, the upthrust and the mass of the object are equal, which means the apparent weight is 0. Therefore, when floating, apparent weight is equal to 0. In this case, therefore, upthrust will be equal to weight in air, which is equal to 13.5 kilogram force. Done. Let's look at the next question. The next question that we do is question number 7. A piece of brass weighs 175 gram force in air. So number 1, weight in air is equal to 175 gram force and 150 gram force when fully immersed in water. So weight in water is equal to 150 gram force. Density of water is given equal to 1 gram per centimeter cube. So density of water is 1 gram per centimeter cube. What's the volume? Why does the brass piece weigh less than water? So let's calculate the upthrust being faced by the brass piece. So upthrust would be equal to volume multiplied with volume of solid multiplied with density of water into gravity, which is equal to loss of weight. In this case, loss of weight is equal to, so upthrust is equal to 175 minus 150, which is 25 gram force. And 25 gram force is equal to volume of solid multiplied with density of water multiplied with G, which means volume of solid is equal to 25 upon density of water. I've removed the I've taken density of water as 1 as given, and I have converted gram force, and there was gravity here, so that gets cancelled. Therefore, volume of solid is equal to 25 centimeter cube. Now, why does the brass piece weigh less in water? The apparent weight is less because of upthrust. Not a part of the numerical, but otherwise your answer would be because of the upthrust, the mass of brass is lesser in water compared to in air. Good. Next question, question number 8. A metal cube of H 5 centimeter and density 9 gram per centimeter cube is suspended by a thread so as to be completely immersed in a liquid of density 1.2 gram per centimeter cube. Find the tension. So tension is basically the weight, that will be the force with which the cube will be pulling the thread, and weight in liquid, which is basically the apparent weight. So that's what we need to calculate. Let's just figure out the volume of solid. So volume of cube would be equal to 5 into 5 into 5, that's 125 centimeter cube. Density of solid is given as 9. I don't really need the density yet. Let's check. And density of liquid is given equal to 1.2 gram per centimeter cube. So we will calculate upthrust. Upthrust would be equal to volume of solid multiplied with density of liquid into gravity. In this case, 125 centimeter cube multiplied by 1.2, and let's convert this into gram force. So this is gram force. 125 into 1.2, that's 150. Yes, 150 gram force. So upthrust is equal to 150 gram force. We still need to calculate the mass weight in air. Oh, we haven't calculated it. So point number 4, mass is equal to density into volume. Correct? Density is equal to mass upon volume. So mass is equal to density into volume. So mass of solid would be equal to density, which is 9, multiplied with volume, which is 125 gram. 9 into 125, this is 900 and 180, 45, so that's 1125 gram. Therefore, weight in air would be equal to 1125 gram force. The upthrust is 150, which means apparent weight would be equal to weight in air, which is 1125 gram force, minus upthrust, which is 150 gram force, which is equal to 975. Yes, that's 975 gram force. Let's check. Find tension in thread. Take G is equal to 10 meter per second square. So I have calculated this in gram force, which means we will need to convert this into Newton. So we know 1 Newton is equal to 100 gram force, which means 975 gram force would be equal to 9.75 Newton. Let's check. 100 gram force is equal to 1 Newton. 975 would be equal to 975 by 100. That's 9.75 Newton. Done. Let's look at the next question. The next question that we do is question number 9. Question 9 says a block of wood is floating on water with dimensions 50, 50, 50 inside water. Oh, so now again volume inside water is given, and like I said earlier, the upthrust acts on the volume inside the liquid. So volume under water is equal to 50 into 50 into 50 centimeter cube. That's 125 with 3 zeros. That's 125 with 3 zeros centimeter cube. Calculate the buoyant force acting on the block. Take G is equal to 9.8 Newton per kg. So since we need to take it work in Newton and kilogram, which means I'll have to convert this into meter cube. So that will be divided by 10 to the power 6, which means 0.125 meter cube. So volume of solid is equal to 0.125 meter cube. We're talking about water, which means the density of water is equal to 1000 kilogram per meter cube. Let's calculate the upthrust. So upthrust is equal to volume of solid 0.125 multiplied with let's check the unit, meter cube, multiplied with 1000 kilogram per meter cube multiplied with G, with saying this is 9.8 Newton per kg. And kg, meter cube and meter cube. So that's 125 into 9.8 Newton. Let's just check these three zeros. Yes, that's 125 into 9.8 Newton. Now we'll have to multiply 125 into 98, 5 into 8, 40, 16 plus 4, 20, 8 plus 2, 10. That's 9 into 5, 45, 9 into 18 plus 4, 22, 9 plus 2, 11. That's 0, 5, 2, 2, 1. So this is 12250. How many decimals? 1. So that's 1225.0 Newton. Therefore, buoyant force is equal to 1225 Newton. Done. That brings me to the last question of this exercise, question number 10. Let's read the question. Question number 10 says, body of mass 3.5 kg. So mass is given equal to 3.5 kg. Displaces 1000 centimeter cube of water when fully immersed, which means volume of body is equal to 1000 centimeter cube. So volume of body, just calculated, which is 1000 centimeter cube. Next, upthrust on the body. So to calculate upthrust, we know upthrust is equal to volume of solid multiplied with density of liquid. In this case, it is water multiplied with G. In this case, volume of solid, that's 1000, density of liquid, which is 1 multiplied with G. So that's gram force, which means this is equal to 1000 gram force, which is nothing but 1 kilogram force. Since the mass is given in kilogram, I have converted this into kilogram force. So upthrust is equal to 1 kilogram force. Second part of the question also done. Let's look at part 3, apparent weight. So for that, we'll have to calculate the weight in air. So weight in air would be equal to mass into gravity. So that's 3.5 kilogram force. And upthrust is 1 kilogram force. Therefore, apparent weight is equal to weight in air 3.5 kilogram force minus upthrust, that's 1 kilogram force. So apparent weight is 2.5 kilogram force. Points to keep in mind from this exercise: density is equal to mass upon volume. Next, upthrust is equal to volume of solid multiplied with density of liquid into gravity. Number 3, apparent weight is equal to weight in air minus weight in liquid, whichever liquid or fluid we are talking about. And I hope you remember the conversions of Newton to gram force and kilogram force. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.